In our last exercise, we created a very simple alignment. It had no curves. It went in a U shape. We added simply 3 segments or tangents to the alignment. Let's look. We're going to edit the alignment by adding curves. And in the process, we're going to learn a little bit about some of the constraints with the alignment geometry. So we're going to open up our exercise file 0603. We see the alignment that we created in our last exercise. And so we're going to select that alignment to get its contextual ribbon. And we want to get that toolbar back that we had when we first were creating the alignment. So I'm going to choose Geometry Editor. And this allows us to add additional geometry, add additional PIs, which would break the existing geometry and create 2 segments. We can delete PIs. We can add simple lines, curves, and segments instead of using the multiple tool here. But notice as we look at these different geometry elements that are part of an alignment, that each one of them pretty much contains 3 different types of constraints. And we're going to focus in on curves because we're going to add some curves here. So you notice you have fixed, floating, and free. What's the difference? Fixed geometry elements, and you have fixed lines, fixed curves, and so forth. Fixed pay no attention to any other members or subcomponents of an alignment. So think about a curve that is fixed. It's going to only pay attention to the geometry or the coordinates itself. So you are fixed to the coordinates of that curve. And therefore, if the tangents that curve is drawn for move, the curve doesn't follow. It is fixed to the coordinates. So often, we don't use a fixed curve, but a fixed line is usually the type of line that we're going to add. That fixed line is going to drive all of the other geometry, and as we change those coordinates, the line itself moves. But if we try to change the curve, it doesn't change the PI of our tangents. It simply adjusts the point of curvature and the point of tangency. Really, we're just adjusting the curve. What about floating? Floating is a mixture of fixed and free. You have one of the ends that is fixed to a coordinate, and one of the ends that is not paying attention to any coordinates. It's freely moving around based upon the geometry that is connected to. A good example of a floating curve may be if your alignment ends in a curve. In that case, you want the alignment to stay tangent to the last line portion of the alignment, but the end of the curve, it has nothing to attach to except being fixed to a coordinate. What we're going to do is use a free curve. A free curve pays no attention to coordinates at all. It doesn't need them. It simply needs the geometry that it's associated with, the lines that it's connected to, the line in and the line out. And it will stay tangent to those lines regardless of coordinates. Now you see the power here of a free curve. Now oftentimes we don't want a free line because we don't want the lines or the PIs to be driven by our curves, but our curves to be driven by our lines. Let's go ahead and select Free Curve Fillet Between 2 Entities Radius. It says select the first entity, select the next entity, and then it asks, do we want greater than or less than 180? We're going to choose less than 180, and chances are you'll always choose less than 180 unless you're creating a loop similar to what you would find on a roller coaster. And then there's all different ways to enter your curve data. We're going to simply use radius, and the default radius in the settings is 200. That's found in our command settings. I press enter. And we can go ahead to the next curve and do the same thing. Once I'm done with the command, I press enter. My labels automatically adjust. Now we have PC and PT labels, and of course our station labels now follow our curve. Now, what is, again, the power of these curves? If I move this PI, notice that the curve moves with it. It will always stay tangent to that PI because it doesn't pay attention to any coordinates. It pays attention to the line in and the line out, keeping a radius of 200 and staying tangent with both. Very powerful. And now you see again the power of having and using the alignment object to create our alignments, even if it's simple geometry. Don't use a polyline. If you use a polyline, the curves come in as fixed constraint curves. And so you don't have as much power, and your curves may not stay tangent, whereas these do. Very powerful to use alignment objects when creating our geometry.